Okay, so this is another example of constructing a truth table, but it's a little bit more complicated because we're going to be working with logical statements P, Q, and R. So we now actually have three different variables, P, Q, and R. And we're going to make a truth table for the following expression. And the expression we're going to work with is this. Not P or R, or P and quantity, not R or Q. So this is quite a complicated expression here, but we're going to follow the same process we did before. We're going to make a truth table consisting of all combinations of our variables, and then we're going to systematically work through and add columns for each part of this expression that we need until we can finally get a final column that is our complete overall logical expression. Okay, so the first thing we need to do is construct our table, and our table is going to consist of the variables we're working with, and the variables we're working with in this case are P, Q, and R. So I'm going to start off with columns for those variables, and we're going to follow the convention that we use, namely that we always start off with all false, and then we slowly build up to all true. So we go FFT, FTF, FTT, TFF, TFT, TTF, and then TTT. So start with all false, and then toggle your way up to being all true. That is the convention that we use to construct our truth tables. Okay, so those are all possible combinations of the logical statements P, Q, and R. Now what I need to do is start adding columns to help me construct a final column for our logical expression I've circled there. Okay, so one of the things I'm going to need is a column for not P, because I have a not P right here. So let's go ahead and make that column. And that's pretty easy to fill in. All I need to do is look at this column and negate every entry. So all the falses turn to trues, and all the trues turn to falses, because I'm negating that. Okay, so that's pretty easy. What's something else I'm going to need? Well, let's go ahead and make a column for this part of my expression, not P or R. Okay, so I already have not P right here, and I have R right here. So to fill in this column, all I need to do is OR each entry like this. So F or T is definitely T. T or T is definitely T. So if there's a T in the row, I'm definitely going to have T. The only time I'm going to have a false is when both of them are false. So there and there. So I can fill out this column pretty easily. So there's a false, true, false, true. Okay, so now we have a column for that. Let's keep going. What's something else I'm going to need? I'm going to need a column for not R, because I have a not R sitting right there. So let's go ahead and make a column for that. That's easy to fill in. All I do is look at this column and negate everything. So instead of false, true, false, true, false, true, false, true, I have true, false, true, false, true, false, true, false. So that's an easy column to fill in. And then you can probably guess what the next column is going to be. Let's continue working on this piece. So we already have not R. Let's go ahead and make a column for not R or Q. So I need to look at this column and this column. And wherever I have a true, I write down true. The only places I'm going to have falses are when both of them are false. So here is a row where they're both false. There's a false and there's a false. So that's a false entry. But everything else is going to be true. So the only other place I have false is right here, where again they're both false. Okay, so we filled in that column. So now we have a column for that part. So let's go ahead and make a column for this. Okay, so let's go ahead and make a column for P and quantity, not R or Q. So to construct this column, I basically need to AND this column with this column, right? So when I AND, I'm going to have a false unless both of them are true. Okay, so we can see that's not going to happen too often. The only time both of these are true is this row. I have that's true and that's true, so I'll have a true there. I'll also have trues here on these last two, because that's true and that's true and that's true and that's true. Okay, so I'm going to have true entries there. Every other row has a false in it, so those are all going to be false. Okay, so we filled that in. And now we're almost there. I have a column for this, which is right here, and I have a column for this, which is right here. So as a final step, I just need to OR those two columns together. Okay, I'm a little out of room here in my table, so I'm just going to call this expression A. So our final column here is going to be for the logical expression A. I just don't have room to write it out fully. And all we need to do are OR those two columns together. So again, I'm going to OR this column and this column. So examining that, any row that has a true is definitely going to be true. The only rows that are going to have a false are times when they are both false. And we can see that there are no rows like that. There's at least a true in this row, and that row is true, and that row is true, because these are all true. And then this next row, I've got a true here, and then the next row I have a true here, and I have a true here and a true here. So these are all also going to be true, okay? Because each row has at least one true in it. So our truth table for this expression is this, and here's our final answer. Here's the truth table for this logical expression. You tell me the specific combination of P, Q, and R. I can go look it up in my table and tell you the resulting value of the overall expression. This expression is actually kind of a special one because it ends up being true no matter what. So this is actually something that we call a tautology because it's something that is always true. That is the end of our example.